But for those who are coming for the first time, we also welcome you for today's session. And without wasting any time, I'll allow Caspar to do the house rules and then hand over to Dr. Host for a presentation. Thank you.
Hello, everybody. Welcome to today's session. We only have a few small house rules for today. We'd like to ask everybody to please mute your cameras to save data and bandwidth. Also, to mute your microphones to keep all the background noise to minimum. If anybody has a question at any point in time, please feel free to raise your hand, or you can use the chat area. Then over to you, Dr. Host.
Thank you, team. As always, everybody's on their posts, and every now and again we have some change of scenery, but also welcome to everybody. I have a very weird situation. I wanted to connect my little camera, this little camera, but for some reason it makes my voice go funny. So I decided rather listen to me, and maybe I'll sort it out by tomorrow. But technology today is not working with me. So, but anyway, welcome. We're now on the M2, so we're on the next, on the 4 sessions. We're on number 2 of the 4 sessions, and how I explained it yesterday was we've done the basic chassis, we've done the basic navigation. Now we're taking it to the next level, and we're adding sensors. And as much as sensors are just awesome and amazing and make the robot cleverer or more intelligent, you've got to make sure that you're getting the right readings. You have to make sure that the sensor is reading any readings. And you have to ensure that the robot is using the data. Please, I know sometimes maybe the robot looks more impressive if you put all the sensors onto the robot. But if the sensors are not performing any function, then rather take them off, because then you're adding weight. And weight on a robot takes power. And so you're fighting a losing battle. I really wanted to show you a couple of things about attaching sensors to robots. And today, I really need to dedicate it to the color sensor. If the color sensor works well, it's great. All right. If the color sensor is not reading correctly, it can cause much stress. All right. And I say this really underlined and in bold, because what we want to do is we do want to encourage our learners. We do want to encourage constructive learning. We do want to encourage them to have a good experience. And so on Thursday, at least, I'll have everything up and running. But so you want the learners to at least accomplish something. Okay, so when we on Thursday, we'll unpack it. When you unpack a whole problem that you have to solve, make sure your learners can at least do something. And if it means without sensors, then at least we've accomplished something. It's a very strange, you want the best robot, and you think the robot's going to be awesome, and then it doesn't actually do what you want it to do. And I have seen teams even at international competitions, especially with a color sensor, where the light comes from different sides, it messes up the readings that the sensors are doing. And then it's just a disaster. So I've got 2 robots here, and I really want to, before I even do the presentation, kind of put it out there. So I'm going to just show you. All right, so I've got this robot, and it's got a color sensor on it. All right. So first of all, the color sensor is in the front. Okay. If you're going to do readings, especially if you're going to do line follow, and maybe this comes just from gazillion years of robots. So if you're going to follow the line, and I'll show you the follow the line. If you're going to follow the line with kind of here, then this sensor should be closer to this wheel. If you're going to follow the line on this side, then it can't be in the center, because otherwise you're not following the line. Okay, and I'll show you that now. Also, it's really exciting to get a Riley rover and put a color sensor on and think, yay, now we're going to do something. Okay, so this is not actually going to work. Okay, and I'll tell you why. There's too much. This, first of all, and I did it on purpose, I don't know if you can see, this color sensor is wiggly. The color sensor must be rigid. Okay, it's taking readings, and quite often it's taking readings. it cannot, this thing is not okay. All right, so this, just plonking a color sensor on, that's not okay. And if you do attach a color sensor, you've got to have, oh my word, it just fell. The wire has got to actually be connected. So if you, it's like if you sit on an airplane, it goes click, click. It has to be connected, otherwise you're not going to get any readings. Okay, so one of my favorite questions is, what is wrong with this? There's a lot wrong with this, because if you put it down, you can, and I've got a book here just to show you that. So if you put it down here, can you see that there is probably about 2 centimeters? So a good test would be your pinky must just fit between the surface and the color sensor. Okay, closer is better than further, but it must be, if you're doing a measurement down, it must be quite close to the surface. All right, so that's the first thing. The other one is, you will notice as you go along, remember I said when we build the chassis, right, and we built a Riley rover, we built a driving base. When you build a little robot, we're actually learning navigation. Okay, if we're going to move it up to do sensors and sensing data and using loops and switches, which we're going to do today, then you need to attach the sensors properly. Okay, so so this is Mario the robot, and you'll notice that the sensors are hidden away. Okay, this is not a design. This is after 10 years of building. So please don't tell the team that they must build this. They need to get there through learning. All right, so there's various, you can start with a Riley rover, then you go to winning design, then you do a core robot, and Casper, you must remind me, there's 2 or more building designs that we can add onto the resources for this MOOC. What you want to guide your learners through the building. All right, but in terms of sensors, first of all, they are solid. They're not going anywhere. All right, the wires are well tucked away. All right, so they can't slip out, they can't get out. And number 3, when the robot drives, this base or this boundary is quite close to the ground, and can you see that the color sensors are then protected from any random light? Okay, that means that if you drive along, you won't get like fluorescent light from the side or coming in on the side to mess up your measurements. Okay, so I just want to show you, for those who have the Spike Prime robotics kit, my team also then designed this one. This is Mario Spike, but also again, the color sensors are nicely tucked away. All right, they are embedded. They're really embedded, and they're not going anywhere. There are quite a few discussions on color sensors, but obviously the safer they are, the better. All right, and then you'll get proper readings. Okay, so that's the one thing about color sensors. Then color sensors can be used for 3 different types of light. Maybe I should get to the presentation. Color sensors can be used for 3 different types of light. The one is the ambient light around us, and I really encourage you to do at least one project with your learners to measure the ambient light. Okay, so a robot will keep moving until it goes dark, or it'll be still until you shine a torch on it, and then it's got to move. So that's the ambient light, which you must measure. So that's the ambient light. The next one is color. And color, please don't assume that color is color, because red is not red and blue is not blue. You'll need to test that it reads it. So what I would always do, especially before you have a class and you tell them to find a red line, just measure it for yourself to make sure that it'll actually pick it up. All right, so testing, that's the color. The third one is a very weird thing called reflected light intensity. And reflected light intensity, they usually abbreviate to RLI value. Okay, so your RLI value. So it kind of rolls and you think, what are they talking about? So it's called the reflected light intensity value, right? And that is a number or a value from 0 to 100. Okay, so if the reflected light intensity is 100, then it means 100% of the light is reflected, and the robot is then detecting the color white. Okay, if everything is reflected 100%, then we are seeing the color white. If, however, the reflected light intensity value is lower, say 1 or 0, then it means 1% of the light is being reflected, and so that's the color black. And now my dogs have decided to bark, but anyway. Okay, so you've got this range of values, and what I'm going to show you just now is to say then, how do you use those values in your programming to follow a line? All right, and all right, so let's quickly do the presentation, and then we'll get to some programming. I've asked Casper to start the Spike Prime, so I will do 2 examples on EV3 lab version, and Casper then volunteered to do those same examples on the Spike Prime Scratch version. All right, so let's just go through the presentation first. 1 minute, so let's just share quickly. Okay. Oh dear, oh dear. All right. All right. Can I just have confirmation that you can see my...
Is connection now? There we go. I can see it.
Can you see it? All
yes.
Right. Okay. So, so we're again, yes, this is kind of follows on from yesterday. It's again in the next series, and we're again doing flow control, but particularly today, we're going to do the color sensor. Can I also ask that when you introduce sensors to your learners, the ultrasonic is kind of easy. It either sees it in a distance or doesn't. A touch sensor is easier. Yeah, I think that's the kind of 2 of the easiest. And then do color sensing. At one stage, we had a noise sensor, and oh my word, it never worked because the robotics classes were always far too loud. So moving on. Okay. All right. And after my presentation, Tumelo will give his MOOC moment, and then we'd love to hear your questions. Okay. So again, for anybody that's brand new to these sessions, this is the iSet Robotics MOOC M2, new site from 2021. New look, lots of extra resources, and I am extremely grateful for everybody who's contributed to those resources. The recordings of these sessions will then be uploaded also to the MOOC site over the weekend. All right. For those of us who've been here before, we really want to equip our coaches. We're assuming you have finished Robotics MOOC 1. If you haven't, it's no problem. Just kind of keep that in the back of your mind. And we're like halfway. At the end of today, we're halfway with the 4 sessions. Okay, so we've done that one. All right, so just some general discussion. The sensors provide the input in your input process output system. Okay, so if you have a senseless robot, it knows 0 about its environment. And I would also kind of caution you to do 1 sensor at a time, that your learners understand each sensor on its own before you start multitasking and you're putting all the data together. It gets quite hectic, and maybe focus on 1 sensor at a time. But you're only limited by the number of ports you have. All right. The color sensor does take measurements, and so I also want to just, if you want to say have a red line on the surface and you want to find it, if you're going to go too fast, you're going to miss it, because remember, you're taking the sensor is taking measurements or readings, so that you can play with different speeds or different power settings and then see how to detect it the quickest. All right. The color sensor. Okay, so I've said that there are. Oh, excuse me. There are different light measurements that you can make with a color set. Oh, sorry. And so linked to the different light settings, there is a thing of calibration. Okay. And I want to also say that many teams, especially at the World Robotics Olympiad, become unstuck because in the one venue we always had, there was always light coming under the curtains. And so it took a while for the organizers to realize, but there's interfering light. Okay, so calibration, you must just keep under the radar because that does need to be explained to your learners. And then proportional line follow. I suppose if I show you the first-hand line follow, then you will see what proportional line follow means. And here's a question: what does PID in terms of PID line follower mean? And I'm not going to give you the answer. You're going to have to figure that out. And yes, there's always a best placement for a color sensor, but it's always not the only space for a color sensor. All right. All right. I'm going to just stop sharing now. I really just need to go and see what my dogs are barking. So, Tumela, Casper, can you just show us how color sensor measurements are used in Spike programming?
I can see if I can try, but my
you have
skills
1 minute. I'm just going to go see
it.
what the dogs are barking at. 1 minute.
Okay. Let me just get here. So let me just show you guys how the Spike Prime looks like. Okay. So we're going to use the Spike Prime. This is what will happen when you open your Spike Prime education. First thing you're going to do is you can start a new project. Here we go. So I'm going to use the icon blocks. Okay, I see they've changed a little bit the program since I last worked with it. So the first thing is we have the start button here, and this is not a okay, here we go. We're looking for a wait button. Unfortunately, it is a little bit easier to do it in Mindstorm, but we'll continue with this. Now I'm struggling with this program. Oh, sorry, it looks like my internet dipped there for a moment. Okay. Dr. Ghosh, you're still muted.
There we go. Awesome. Okay.
Unfortunately, Dr. Ghosh, it looks like they've changed this program a lot. I haven't yet had time to check what is the new things on this thing.
Okay, no problem. No problem. We'll get there. We'll get there. All right. So what I'm going to do now, I'm going to show you how to use the color sensor data in your programming. And I'm just going to share here. Yeah, there we go. Can I just confirm that you can see my screen?
Yes, Dr. Ghosh, I can see.
Awesome. Okay, so now we've got, say, a loop. All right. There we go. There's my loop. All right. So we want to continue moving until the color sensor detects say a red line. Okay. So then that means that this is the gate out of it. So until your color sensor sees, okay, and it's going to see black. All right. So say a black line. All right. So what is going to happen when it sees a black line? It means that your two motors that are running, that we've put on must then be switched off. Okay, so now your robot, remember, whatever you put on, you have to also put off. So here's your robot, it's running, and if it sees a black line, it will then stop. Okay, but so also, oh, it's connected in port number 3. But so too, if you change that, oh no, hang on a minute, let's just first change. If you say, no, let's make it, if it sees green or yellow or red, any of those colors, then it will stop. Okay. If that line is too narrow, it's not going to pick it up. Okay. If there's interfering light, it's also not going to pick it up. Okay. Right. Let's change the example. Now we say your robot has stopped. Okay. And as soon as the ambient light increases, it must start moving. Okay. So then this is off. Your robot is off. And this must make it go on. All right. No, it's not. Let's just make it on for rotations, not on forever. So say for must move forward for 6 rotations. Okay. What is going to make it move forward? If the color sensor, if the ambient light, okay. All right. If the ambient light, what? Let me just go here. Ambient light. Okay. If the ambient light is less than, so if it becomes dark, but what happens if we say if the ambient light increases? Okay, so if you shine a torch on it, it will then start moving. Okay. Okay, so now a really important with the color sensor is you need to give your learners enough examples for them to figure it out. Okay, and so this is the color sensor correctly connected, and this is the ambient light. We've done the color and we've done the ambient light. The ambient light is around. You can also say as soon as the light increases, it must make a noise. Okay, so learners love to make let the robots make a noise, and there's always a sound. So it'll maybe snore here, maybe a sleep sound. I don't know. Is there a sleep sound here? Okay, so it'll go boing, boing, boing until you shine the light on it, and then it will stop making the sound and it will move forward. Okay, that's just the color sensor on ambient light. All right. Now I am going to do a new program, and I want to explain to you what how to follow a line. Okay, and for that to happen, I actually needed to maybe. All right, let me just, if you were, I'm going to explain it to you, and then we will also demonstrate it on Thursday. All right. So if you have maybe a white surface and you stick a piece of insulation tape down, and now you're going to follow the line, what you're doing is following the edge of the insulation tape. And so if you kind of make a little funnel over your eye, and often I give the kids toilet rolls so they can kind of stare down at it. So if you stare down and you're following it on the left-hand side. So if you stare down and you see only black, that means you are veering towards the center of the road. Then you need to move towards the left. If, however, you look through your little color sensor tunnel and you see only white, you're going to have to move back onto the road. So you're going to move towards the right. Okay. So how does that translate into a program? Okay. So first of all, we're going to keep moving. Okay. And we're going to keep moving. We're going to keep moving for, I don't know, 10 seconds, or let's just give it a count at a time. Let's just go 20 seconds. All right. Normally we do something else, but say we're going to go. All right. Now we're going to follow the line. Okay. So the follow the line says we need to decide whether we get, and the follow the line is a kind of a wiggle. All right. Okay. So I'm going to put it in here. Sorry, this is now going off my. Okay. So we are the sensor we're going to use is our color sensor. We're going to compare, and we're going to reflected light intensity. Okay. range of reflected light intensity values is between 0 and 100, then the middle value is 50. So that's why we choose this 50 value, okay? If you calibrate your light sensor and you see the values are between, say, 20 and 80, you add the two together and get the halfway, which will then also be 50. So that is where this value comes in, and I'll explain it more later. Okay. So what you're doing is you're controlling your B and your C motor. So it's a good idea to kind of have two. There's a B motor and a C motor. Okay, let's just put that. Let's put that at B and this one at C. You're controlling your two motors, and I will explain now how we get to that. But I thought it important that I just show you how I got to this answer. So B and C. Okay, so let's put the motors just on and on and on. Okay, this is not the answer. I'm just gonna say, all right. If you hold your little toilet roll over the road and you see it's less than 50, so it's black, okay, then you must veer, and our standard robot is B on the left and C on the right, okay. If you only see black, you've got to move towards the left, okay, and to move towards the left, B must go on and C must go off, okay. And if you see more than 50, this is this one here, okay, then you're seeing white. And if you're seeing white, then B must go. Is everybody with me? No. Then B must go on and C must go off. If you're seeing white, yes, then B must, if you're seeing white, then you must go the other way. So B must go on and C must go off. If you're seeing black, then C must go on and B must go off. Sorry, there we go. Okay, so this is the first kind of chance. I normally start at 30% power, only because it's the wiggle. So this is your very first wiggle program. Okay, so wiggle, 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 wiggle. It follows the line. And as your learners get comfortable with follow the line, then you start changing the values. Okay, so instead of putting it off, you can put it on 10% power and 10% power. So it's a little bit smoother, all right? One sensor, we're only using one sensor, and the robot can follow a line. Okay. So now and you just see by Thursday we'll get to the point where we say, okay, so now we've got one color sensor following the line. Now we can put an ultrasonic in front and say, we'll follow the line until the ultrasonic detects there's an obstacle in the middle of the road. Okay, and then what you would have done then is change this to the ultrasonic sensor. Why can I not see? There's ultrasonic sensor, and the distance is less than 20, and then it must stop. So it follows the line. Now we've got two sensors already, you see, and this is where the so-called artificial intelligence comes in. It's merely reading values from your environment. Okay, I'm going to stop sharing this, and I think I need to just finish my presentation because I think we're getting.
Okay.
We're running.
Dr. First, we did have a hand.
Oh, sorry. Yes.
Nishan, if you want to maybe unmute quickly.
I had a question about the calibration of the color sensor, but I think you've answered that. Okay. I just wanted to know whether it's outside the programming structure.
Say again?
Whether the calibration of the light sensor is outside the program. It's unlike the motors where you've got to reset them within your program.
Okay, so so the calibration is we let the learners have about 10 minutes before they run a robot to calibrate. And so the initial one would be to say find the dark value, find the light value, and then work out a calibration value, and that you can put into a file, and so the program will read the value from a file. Okay, but as your students get more as they get more experience, you can show them how we put values beforehand into files, and we read values from files. Yeah. Okay, so you can program it into your robot, but we don't want to overwhelm our students with things to remember. So let's first do wiggle, wiggle, wiggle robots and assume in an ideal world it's between 0 and 100. Then we can calibrate. We take 2 readings, find a value just to confirm that our middle value is 50, and then we'll move on. Yes. Okay. Awesome. Okay. All right, let's get on with the presentation then. Oh, come on. Here we go. Tell you. There we go. And we're going to just confirm.
It's going through. Yes, I can see it now.
Awesome. Okay, so the focus today is then how do we use color sensor data in repetitions and in decisions. And so the repetition would say, which I showed you just now, is repeat the loop until you see a black line, until you see a red line. Okay, a decision would say, if you see the reflected light intensity is less, then you've got to veer to this side, and if it's right, you've got to. So there's always a decision that you have to make. Okay, and then as I showed you just now, also you can put multiple sensors onto a robot, but start please with one sensor at a time. All right. I've spoken now about attachments of sensors. It's really important that it's well attached with a wire and with the connectable pins. All right. So here it's attached rigidly in front. If you see here in front of the Riley rover, and the wires need to be corrected. I cannot stress that enough. I have had teams at international competitions and they got their wires crossed. And luckily the team was gracious enough to laugh about it and not to throw a temper tantrum. But it becomes stressful for learners, especially if you're participating in competitions. And so they must be very aware that it needs to be correctly connected. Okay, so I've explained about the color on the spectrum, the ambient light, which is the natural light, and then the reflected light intensity between 0 and 100. All right, and the sensor turns red if you're doing reflected light intensity, and then it's like a dim blue if you are measuring the ambient light. And I'll show you just now on port view, you can see which color set that is. All right. How do you attach a color sensor? Well, that depends on the purpose. Okay, so if you want to have the ambient light, you'll have it facing up. If you want it down on the ground and following a line, it'll be down closer to the wheel. And there are some teams that have used a color sensor very effectively on starting different programs. And I think I maybe need to show you that as well. And then, of course, the wire to connect it. All right, so detect a line. It should be able to, the robot should be able to detect a line, and it should be able to follow a line. Just on the detect a line, if the line is too thin that it must detect, it's going to miss it. All right, that is just one of those things. All right, and then for the ambient light, make sure there are no shadows. All right, and it must be close to the ground, and you will always get a value on the threshold. If you're not getting a value in the range, then there's something wrong with the color sensor. And also on that, it remains electronics. So if your learners are going to drop them, they're going to break. Okay, that is what it is. And so we're back to the right in the beginning. One of my first comments was there has to be respect for these sensors. They remain electronics. Okay, and they break. Okay, I've showed you flow control at the bottom, and I've shown you how to link the different values: the color, reflected light, and the ambient light. And of course, that's exactly what the value that I did. Less than or greater than, you can use different light values. The ambient light, that's the symbol for ambient light over there, which is really cool. And the programming to detect a line, so that was to detect just a red. Okay, and really a good way is to put little labels on so that you understand what your robot is actually doing. Okay, so here if it's moving and if the ambient light becomes greater than 50, well then we stop. Okay, all right. This one, it says we're going to keep moving. All right, and this is a wait until this ambient light increases. It increases by 10, by a value of 10, and then we stop. Okay, again, a different way of controlling. This is just a weight. A weight icon only refers to the icon, to the programming icon in front of it. So it's not like a looping which has multiple icons. All right. Please first get the zigzag line follow right, and then you fine tune it. Please don't expect your learners to know how to do PID, proportional line follows. No, it's just, we want to encourage them. All right, there's my line follow that I did as well, but this is the version of it that I created a while ago. And okay, so to calibrate your reflected light intensity, you need to be confirmed and measured. That's why I said it's currently not included in your programming, but experienced teams have a calibration program that they write to read values. Okay. There are some really cool videos on reflected light intensity and following lines. Most teams usually have 2 color sensors in front so that they can cross intersections. And this video is really interesting, how you get a robot to follow a line with the one and measure the intersections with the other one, with the other color sensor. And so there's you've got one color sensor, but you're doing multiple purposes for it. So please, first one sensor at a time, that your learners understand that. Okay, and here, I don't know who asked the question, I can't remember, but storing the calibration value, here's a video, and then you can put it into a text file, and so you retrieve it from a text file, usually into a variable or into a constant in your programming. All right. And so we come to homework. All right, so there's some quizzes there, there's lots of building and programming activities, and I really encourage you to try at least some of them. Because this is learning by doing. This is not learning by listening. So do a little bit further. And if you have any questions, please contact us. You can contact ISET for general queries, but also if you want help accessing the MOOC content, Tumelo and Nadine will very graciously assist you. All right. And so that is the end of my official presentation. I'm going to just stop and ask, are there any questions before I do some more demonstrations? Let's just have a look.
Yes, we have one from Eric.
Hi, Eric. Yes.
I just want to make a comment on Spike Prime.
Yes.
You can't get the readings from the color sensor as you can from EV3, because I believe it you can read the values on the brick for calibration. But on Spike Prime, you've got no way of calibrating the values. You don't know what they are.
Eric, can I
Do you
get back to you
understand
on
what
that?
I'm saying?
Can I get back to you on that one?
It looks very funny, trust me, Dr. Gous. I've seen the program just now.
You can't calibrate on Spike Primes.
I'll show now.
What I'm saying is on Spike Prime, the color sensor reads the values and everything, but there's no ways of knowing what the value is.
Oh, wow.
Whereas on the demonstration I saw on EV3, you can actually read the values on the brick.
Yes, yes. Okay. Okay, now you've given me homework.
Okay.
That's interesting. That's very interesting. Oh my goodness. That's not going to be great. Okay, I will see what I can do. I'll get back to you. Okay. Thank you. Sure. I didn't realize that. You see how long I've been working with EV3s, eh? Okay. Anybody else? Thank you, Eric. Thank you for that. Anybody else got a comment or something to add? Do I need to repeat? Anybody got anything to add?
Okay, so Dr. Gous, I haven't worked with the Spike Prime. So just a question on Eric's comment there. Can you ask the brick to display any of the sensor values?
Yes, yes.
So can you ask it to display the sensor value then?
Yes.
Maybe that's a solution to reading the value, Eric?
I think we're going to have a workshop on this.
Yeah, unfortunately not, because there's actually no ways that I've seen that you can get any values out of that the sensor into the brick or to display it or to access it.
Okay.
Whether it's on what in the demonstration I saw on EV3, you can actually see the values that it's reading, and then you can use those values. But there is no ways to do that in Spike Prime.
Okay.
I don't have an EV3.
Okay. No, we'll have a look. We'll figure this out. Absolutely. Right.
Dr. House?
Yes.
Yeah, this is how the program looks now.
Hey, and this is Spike Prime.
Yes.
Okay.
Yeah. Now this is the one that they were talking about, the color sensor.
Is this not Spike Essential?
No, this is, I did choose the not the essential one.
Okay, I need to get my new laptop up and running so that I can get with this conversation.
As soon as you get it right, I will.
Monday's going to be a long day.
I'll come through maybe and then help you with that one.
Awesome.
I see,
awesome.
Eric, your hand is up again.
I just want to make a comment. The blocks you chose are the small blocks. We actually need to choose the word blocks. That's far more intuitive in terms of programming, and that's one level below going Python.
Yeah.
So.
Okay.
Yeah, I've been so busy with my exams, I haven't yet got a got the chance to do this.
All good. All good.
Fantastic. So, okay, sorry. I thought you were going to show us the Casper on that view.
No, not yet. Dr. House will. No.
Okay, so just what I want to show, I'm going to quickly start my robot here. Start Mario quickly. One more thing. I see our time is kind of running out, but I just want to share with you quickly here. You think by now I know how to share my screen, hey? All right. So here is the program, and okay. So there's the little star, which means I haven't saved. So let me just do this save project. So project. Okay, project A. All right. And then I'm going to, if I go down here and I say refresh, now Mario is standing right here and he should connect. I would recommend that you teach the learners to use the USB cable first so they understand that we are downloading the program. With the Bluetooth thing, here we go. With the Bluetooth thing, it goes sometimes too quickly, and then we find robots running off the table. Okay, so let me just show you. If you go to port view here, okay, then you can see Mario has got a color sensor in port number 3. We've got a motor in port A, another little motor in port D, and then 2 large motors in port C and B and C. All right, so in theory, okay, so I'm going to see whether this robot is going to actually behave itself. Let's have a look. So if I run this program, okay, it's working absolutely perfectly, and you'll have to take my word for it, and I will get the camera out and I will show you. So it does. It's not going to stop because it doesn't have, you see what the problem is here. It's going to stop when the ultrasonic, now it hasn't told me that I don't have an ultrasonic. It's just going to keep moving. All right. That's not a good idea. Okay. However, if I had said here, if I put this to port number 2, and that is port number 3, then we actually have a mistake. And if I run it now, it's not going to do anything. All right. And you see it's running and it's running and it's running, and it's not getting a value, not getting a value, not getting a value, not getting a value. So I think part of your role as a coach is to identify the errors that your learners are going to make. All right. So number 1, always check. That's port number 3. So that must be port number 3. It says in port number 4, there's an ultrasonic. There ain't no ultrasonic in port number 4. That is why your program is not running. Okay. This thing works perfectly. So if we change this to time, make a timer and go on to, oh, no, not that one. Just move here quickly. Time. And we'll make it 5 seconds. And I'm going to pull this Mario robot back. I really should have sorted this out. Okay, let's have a look here on that side. And here we go. So now it's going to run without any errors. There we go. And it's following the line absolutely perfectly. I don't know if you can hear zigzag, 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 zigzag. And 5 seconds, and then it stops. All sorted. Okay. And just kind of on a last note, we use building instructions to create a frame of reference for our learners on how to build robots, and then we teach them to modify it. It is the same with programming. To translate a problem into a solution, I really highly recommend that you create this code with them, show them point for point why you do it, then ask them to do it. Okay, and then we can say, okay, so what will happen if, and then don't do it for them, but say what will happen if we make this say 50. When we put it on to 50% power, and instead of putting it off, we put it on to 10%, say 10%, and we put this on to 10%. And then you have a discussion in your class and say, okay, so what do you think will happen if we do it like this? And I'm going to tell you what's going to happen. Just put my robot to start again. Okay, so if I run it like this and download and run, so it's swinging away here. It's got a much less defined movements because 50 and 10, and they need to talk about that. All right. I don't think 50 is a good idea, and I will tell you why. It's because if you go around curvy roads, it's kind of chaos. All right. All right. I'm going to stop here again. You can see I haven't saved my program, so let's just save it. Save project. And there we go. All right. Any questions? Any other questions? Or can I stop sharing? There we go. It's been hectic. I acknowledge that there's a lot of learning, especially with color sensors. And really the only way we're going to kind of instill this learning is not through rote with our learners, but letting them build a robot with a color sensor and figuring it out. All right. All right. So on that happy note, seeing that there's no more questions and no more comments, I'm going to ask Cabello, do you want to just close the session for us? Oh, Eric. Yes. Sorry, Eric.
Just a quick question. I just want to qualify on Spike Prime. If on the interface, and you've got at the very top of the interface are all the sensors. So, for example, the ultrasonic, if you move your hand or move it away, it actually shows you what the sensor's reading.
Yes.
Yes. But it doesn't show you on the robot. So what I was talking about earlier was particularly the color sensor.
Okay, but it will show you. It will show you the values. I need to figure this out. Yeah.
So I've looked at that because I've been looking at this M2 for a bit now, and I found a nice article on how to do that. Okay. But there's no ways in Spike Prime that you can get the readings and do those calculations. Just a quick question on the M2 on the submissions, where you've got the comments. Can those be written out, or do you want them in the video?
For what is this?
So in the submission, so you got to submit a video, and then you got to comment on the timing, the 10-second or the 30-second or whatever.
Yes. On the portfolio.
Yeah. Yes. Do those comments, could they be written out, or do you want them in the video? Or
you can write them in the document as well. You're welcome to do that.
Okay.
Especially if you want to maybe take the video and then add your comments afterwards. That's also cool.
Okay. All right. No, that answers my question. Thank you.
Okay, but we will solve this problem. We will. Eric, you and your Spike, and me and my EV3, and we'll figure this out.
Okay.
Okay.
Well, I just think
we'll add all these resources.
The way it's been made, Spike has been made, so it's not that that detail. So you can't. That's just a nature of how it's been made.
Okay. I'm going to see how far I can push it. Let's have a look. All right. Okay. Awesome. All right. Thanks, Eric, for that. Thank you for keeping us on our toes, and we'll figure this out. All right. Okay. Cabello, you can close the session now. Thank you.
Thank you, everyone, for attending today's session. I want to confess, Eric, myself, I've never worked on Spike Prime also. So what you are saying now is actually giving me a challenge to actually go and look at it. But we really appreciate questions like this because we can only improve from them. And without wasting any time, I'll ask Caspar to stop the recording and until we see each other tomorrow. Thank you.
Thank you very much. Absolutely, Cabello. I second that. We need to have fruit salad and Spike Prime on Monday when we get to the hub. Okay. Thank you, everybody. Thank you. Stay well, and we'll see each other tomorrow. Bye-bye.